Today we're hiking through a terrain from a start point to an end point. The start point has the elevation A, just as its neighbors, and the end point has the elevation Z. And we can only ever go from one letter to one more, so from A to B, for example. So let's immediately look at the examples. So here is where we start, and then we can go to the other A's. They are at the exact same elevation. There we go. From there, we can go to A, B, or B. There you go. And from here, we can go to A, C, C, but not to Q. Note that the Q remains unvisited because, well, from B to Q is simply too much, right? We can only go from B to C, but not higher. Okay, and if you concentrate, for example, on this terrain here, and I scroll down a bit, then you can see how we slowly approach our end goal. And the last steps go from Y to Z and from Z to Z. And this Z is our end Z. Right, so let's see how exactly I did that. So first I pre-processed the terrain a bit. So this one string with the clouds above and the clouds below, those are just guards. This is the highest ASCII value there is. So I will never climb from A to cloud. Right, and then here the line breaks and spaces. Right here I also replace with single clouds. So I have a one-dimensional string. Then I count how many clouds are there in succession. That will be 9, and that is our width. And then I can compute the directions. Left is -1, right is +1, up is minus width, in our case -9, and down is plus width, in our case +9. Right, the start is the index of the S, that would be here at index 9. The end is the index of E, that is index 32 right here. And then I replace the S with an A and an E with a Z, so I don't have to special case them later. Right, and here I transform the immutable string into a mutable array because I will mark positions as visited later, and the visited mark is just another cloud as a byte with a value 126, biggest ASCII value. Right, and then I have a vector of hikers. Initially, there's only a single hiker. Its position is at the start. The height is the smallest height, elevation 97 or A, and the distance is 0 from the start. Right, so just the one hiker. Then I destructure all the hikers into position, height, and distance, and I will only keep those where this condition is met. So if the terrain at that position is not marked as visited yet, then I will mark it as visited. And A set will return the value visited. So that counts as true. And if I don't have an else clause, that will count as false. Okay, then the maximum allowable height is 1 more than my own height. The distance to the potential new neighbor is 1 more than before. And then I loop through all the directions, all 4 directions. Then I compute the new neighbor position and I look up how high that terrain is at that position. And of course, I can only keep those that are at most the maximum height. That's why the Q was excluded previously. Okay, and then I put it back into a vector for later destructuring. Right, but when are we done? When have we found our end position? So here I filter my hikers with this filter function. So I destructure again, and then I simply check if the end and the position are the same. So if we have reached the end position, that could be multiple winners in theory. Here I pick the first one via destructuring, then the debug output. And if I found a winner, then I look at the distance of the winner. That's the result that we shall return from the function. Otherwise, we simply recur again, right? And that will perform this flood fill, if you will. Okay, so I'm quite satisfied with this. And then for part 2, maybe let's look at the output for part 2. Where does that start? Here. For part 2, we shall find the shortest hike from any A starting point. So we don't have to pick this guy. We can pick anyone. Now we could try simply all the A's and then pick the shortest. But why don't we simply start at the end and then work our way in the other direction, and then as soon as we hit an A, we can stop. I guess this is the smart solution. Okay, so you should see the spiraling out here in the opposite direction. And when do we actually stop? Yeah, so here at the end, we found an A apparently. Okay, so what do we have to change in the code? I marked the changes. They are not too many. So here's one change. Of course, the first hiker starts at the end instead of the start, and the elevation is Z instead of A, but the distance from the end is, of course, still 0. Then we compute a minimum height instead of the maximum height. That is 1 less instead of 1 more. And then the acceptable heights are at least the minimum instead of at most the maximum. Right, and here the condition for the winner is different. We check if the height is equal to the A elevation instead of reaching the end position. Right, and the rest is exactly the same. So part 1 took me quite a while, but as soon as I figured that out, the delta to part 2 was maybe 5 or 10 minutes.